Hello, in this short lecture I will give a proof of the Pythagorean theorem. Actually, the Pythagorean theorem says that in a right triangle the square of the hypotenuse is equal to the sum of the squares of the perpendiculars. So actually, if we look at this triangle, then we can say that the square of the hypotenuse c square is equals to the sum of the squares of the perpendiculars, that is a square plus b squared, or c square is equals to a square plus b square. Okay, so let's assume that the right angled triangle ABC is the right angle that we want to prove that a square plus b squared equals to c square. And now we actually made a copy of this right angled triangle. We built it along the length of side A. We actually drew side B and raise a perpendicular whose length is length of side A. So here is side B and here is side A that is actually perpendicular to side B. So actually this angle is 90 degrees. Exactly as this angle that is also 90 degrees. Now we have two triangles, this and this. Okay, ABC and ABC, the right side and the left side. We have two triangles whose two sides are equal to each other, side A and side B. So side A here in this triangle is equal to side A in this triangle, and side B in this triangle is equal to side B in this triangle. And also the angle between those two sides equal to each other in both triangles. The side A and side B, the angle between side A and side B is 90 degrees. Okay, here we built it like this, and here it was 90 degrees because it is a right angle, a right triangle. Okay, so therefore the triangle ABC in the right side coincides with triangle ABC on the left side according to the rule of side angle side. Okay, side, angle, and side. That is to say, two triangles that have two sides that are equal to each other, and also the angle between these sides is equal to each other in both triangles, so the triangles are congruent. Okay, side A equals to side A, side B is equals to side B, and the angle between side A and side B is 90 degrees here, and the angle between side A and side B is 90 degrees also here in this triangle. Therefore, these two triangles are coincides. They are congruent. Okay? And since the third side of the triangle ABC on the right side is C, the third side of this triangle ABC is C, then because of the overlap of the two triangles, the first side of triangle ABC on the left side also C. Okay? Because of the fact that those two triangles coincide, and this side is C, this side also must be C. Okay? Let's mark the angle between side A and side C with alpha. The angle between side A and side C will be alpha, and also the angle between between side A and side C will be alpha. Okay? As we know, the sum of the angles in a triangle is equal to 180 degrees. In every triangle, the sum of the three angles in a triangle is 180 degrees. Therefore, the angle between the side A and side C will be, if we mark the angle between side B and side C as x, then the angle between side A and side C is, in total, we can say that alpha plus 90 plus x is equals to 180 degrees. Okay? As you can see here, x plus 90 plus alpha equals to 180 degrees. And therefore, we can deduct 90 from both sides of the equation, and we can subtract alpha from both sides of the equation. We will get that x is equals to 90 minus alpha. Okay? The angle x is equals to 90 minus alpha. and since the sum of the angles on a straight line is 180 degrees, then the angle between the sides C and C in the middle triangle, the angle between C and C will be, we will mark this angle as unknown y. Okay, we will use the variable y to mark this angle. We can say that alpha plus y plus x that equals to 90 minus alpha is equals to 180 degrees because of the fact that the sum of the angles on a line, on a straight line, is always 180 degrees. So we can say that alpha plus y plus 90 minus alpha equals to 180 degrees. As you can see here, alpha plus y plus 90 minus alpha is equals to 180 degrees. And actually, alpha minus alpha is equals to 0. And then we will subtract 90 degrees from both sides of the equation, and then we will get that y is equals to 90 degrees. Okay, so here y is equals to, angle y is equals to 90 degrees. Okay, on one end, now we will calculate the area of this trapeze. Okay, we will calculate the area of this trapeze by two ways. On the one end, the area of the trapeze is equal to the sum of the parallel sides. A is parallel to B, so the area of the trapeze is equal to A plus B. Multiply the height of the trapeze. The height of this trapeze is A plus B, so it is A plus B multiplied by A plus B, or A plus B squared, divided by 2, or in mathematical notation it is A plus B times A plus B, the sum of the sides A and B, divided by the height, that is A plus B, divided by 2, is equal to A plus B times A plus B divided by 2, or A plus B squared divided by 2. On the other end, the area of the trapeze is equal to the sum of the three triangles, this triangle, this triangle, and this triangle. And actually, the area of this triangle is A times B divided by 2, so is the area of this triangle is B times A divided by 2, and the area of the middle triangle is C times C divided by 2. So in total, the sum of the areas of the three triangles will be A plus B divided by 2 plus A plus B divided by 2 plus c squared divided by 2. As you can see here, a plus b divided by 2 plus a plus b divided by 2 plus c squared divided by 2 equals to 2ab divided by 2 plus c squared divided by 2. It is actually a times b, because the 2 is 2 divided by 2 is 1. So actually by comparing the two expressions we got, we will get the Pythagorean theorem. So we actually calculated the area of this trapeze in two ways. First of all, we said that it is actually the sum of the parallel sides, that is a plus b, multiplied by the height, that is also a plus b, divided by 2, or it is a plus b squared divided by 2. And the second way that we calculated the same area is we actually say that it is the sum of the area of the three triangles, this triangle plus this triangle plus this triangle, that is actually a plus b divided by 2 plus a plus b divided by 2 plus c squared divided by 2. So we can compare the two expressions that are equal because it is the same area of the same trapeze. And then we will get that a plus b, in the first way that we calculated the area of the trapeze, is we got that the area of the trapeze is a plus b squared divided by 2. And the second way that we calculated the area of the trapeze is actually the sum of the areas of the three triangles, and it is a plus b divided by 2 plus a plus b divided by 2 is ab, and the area of the middle triangle is c squared divided by 2. So we can compare the two expressions of the area of the trapeze, and actually here we can multiply both sides of the equation by 2, and then we get a plus b squared divided by 2 times 2 is a plus b squared, is equals a times b multiplied by 2 is 2ab, and c squared divided by 2 multiplied by 2 is c squared, and then a plus b squared is equals to a plus b times a plus b, equals to 2ab plus c squared, and we will open the brackets. A times a is a squared, and plus ab plus ba plus b squared. If we open these brackets, you will get that it equals to a squared plus ab plus ba plus b squared equals to 2ab plus c squared, and then we'll get that it equals to a squared plus 2ab plus c squared equals to 2ab plus c squared. And if we deduce from the two sides of the equation 2ab, then we will get that a squared plus b squared is equals to c squared, and this is exactly is the Pythagorean theorem that actually says that the uh, the square of the hypotenuse is equal to the sum of the squares of the perpendiculars. Okay, a squared plus b squared is equals to c squared. Okay, so that is one way to prove the Pythagorean theorem. Actually, I think that there is about 30 ways to prove this Pythagorean theorem, and I actually gave you only one way, but you can find more ways to prove the simple Pythagorean theorem. Okay, thank you very much.